I'm sure you're keen to have a look at the basic syntax, so let's jump into that first. A lambda then is basically an anonymous block of functionality. It's a lot like using an anonymous class instance. For example, if we want to sort an array in Java, we can use the array sort method, which takes an instance of a comparator. It would look something like this. The comparator instance here is an abstract piece of the functionality. It means nothing on its own. It's only when it's used by the sort method that it has a purpose. Using Java's new syntax, you can replace this with the lambda, which looks like this. It's a more succinct way of achieving the same thing. In fact, Java treats this as if it were an instance of the comparator class. We can see this if I were to extract a variable. Notice its type. The lambda is of type comparator integer, just like the anonymous interface above. Because comparator has only a single abstract method in it, compared to, the compiler can piece together that when we have an anonymous block like this, that what we really mean is an instance of comparator. It can do this thanks to a couple of the new features that we'll talk about later, functional interfaces and improvements to type inference. So in terms of the syntax, you can always convert from using a single abstract method to using a lambda. For example, let's say we have an interface example with a method apply, returning some type and taking some argument. We could instantiate an instance with something like this: new example, override the method, implement the body. And to convert it to a lambda, we basically trim the fat. We drop the instantiation and the annotation. We drop the method details, which leaves just the argument list and the body. We then introduce the new arrow symbol to indicate both that the whole thing is a lambda and that what follows is the body. And that's our basic lambda syntax. Let's take the sorting example from earlier through these steps. We start with the anonymous instance and trim the instantiation and the method signature, introduce the lambda, and we're done. There's a couple of optimizations we can do though. You can drop the types if the compiler knows enough to infer them. And for simple expressions, you can drop the braces to produce a lambda expression. In this case, the compiler can infer enough to know what you mean. The single statement returns a value consistent with the interface, so it says, no need to tell me that you're going to return something, I can see that for myself. For single argument interface methods, you can even drop the first brackets. For example, a lambda taking an argument x and returning x plus 1 can be rewritten without the brackets. Let's recap with a summary of the syntax options. The first example is the most verbose way to create a lambda. The arguments to the function, along with their types, are in the parenthesis, followed by the new arrow syntax, and then the body, the code block to be executed. You can often drop the types from the argument list. The compiler will use type inference here to try and guess the types. It does this based on the context that you're trying to use the lambda in. And if your code block returns something or is a single line expression, you can drop the braces and return statement altogether. In the case of only a single argument, you can drop the parenthesis, and if you have no arguments at all, the hamburger symbol is needed. In the interest of completeness, there is another variation, a kind of shortcut to a lambda called a method reference. So this last one is actually a shortcut to a lambda. We're going to talk more about these later, so for now, just be aware that they exist and can be used anywhere that you can use a lambda.